Hi everyone, today in Integrated Math 1 we're going to go over Chapter 13, Lesson 4. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over what the properties of rhombi and squares are. So a rhombus. When we're talking about a rhombus, we're talking about a parallelogram. Remember, parallelogram has the word parallel in it, so parallel is going to be very important here. And we also know that four sides are congruent. All four. So we have this side, we have this side, and this side. And they're all congruent to each other, so they're all the same length. Now we're going to go over another two characteristics in just a moment. Then we have diagonals of a rhombus. If a parallelogram is in fact a rhombus, then its diagonals are perpendicular. When I'm saying perpendicular, remember, we're talking about making a 90-degree angle. So, as you can see here, we have rhombus ABCD, and we have side AC is perpendicular with side BD, which makes the 90-degree angle, which means all of these are also 90 as well. Then, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So we have, if rhombus NPQR is in fact a rhombus, then 1 and 2 are congruent to each other, 3 and 4 are congruent to each other, 5 and 6 are congruent to each other, and 7 and 8 would also be congruent to each other. Alright, so let's go over all these different names. So first of all, parallelograms have opposite sides that are parallel, just like in the name parallel. When we're talking about rectangles, we're saying that we have 4 right angles, always for rectangles. However, rhombi has 4 congruent sides, as you can see here. And the squares is like if we had the rectangle and the rhombi and they had a kid, then they would make a square. They have 4 congruent angles, which happen to be 90 degrees, and all the sides are also congruent to each other. Alright, so let's go over some more theorems. So, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So, we have the diagonals, in our case, we have JL is perpendicular to KM. And that's because they make that 90-degree angle. Because of that, we know that JKLM is actually a rhombus. So it's more specific than just saying it's a parallelogram. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So this one is, notice it says here the converse in both of these. Well, when it's saying the converse, it's like the flip version of this. So these should look pretty familiar because we did go over it, except in the reverse. This time we're saying if we have angle 1 and angle 2 that are congruent, and 3 and angle 4 that are congruent, or 5 and 6, and 7 and 8 that are congruent, then we have a rhombus. Before we said if we have a rhombus, then these angles are congruent. So then we have, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So here, consecutive, remember it makes like that C. So here, these are the only two that are marked that they are congruent. So I'm going to go by this one. So side AB is congruent to BC. And these are consecutive sides. Because of that, I know that ABCD is actually a rhombus. Last but not least, if a quadrilateral is both a rectangle and a rhombus, then it is a square. We just talked about this. It's like if a rectangle and a rhombus had a kid, the kid would be a square. And there we go.